physics, this little triangle that has dvt in it? So what goes on the top? Just like I say, dvt. Do you know how to use this triangle?
Not yet. Distance.
Yeah. Distance is velocity times time. That's how you read it, right? If I want velocity, that would be distance divided by time. You see how this works? And then time would be distance divided by velocity. That's how you use the triangle? You've never seen this before? Oh, interesting. So if you want to drive 200 miles and it takes you 4 hours, what's your average speed? Will you take your distance and divide by time?
It actually wouldn't work.
So it would be 50 miles per hour. Yes?
It wouldn't work for time because time equals velocity for t.
Okay, so here's where it starts getting confusing because there's what's called average speed and instantaneous speed. So when you look at your speedometer and you read 65 miles per hour, that's at that instant what you're driving. This is over 4 hours your average speed. You see the difference between the two? Okay, so for our purposes, our average velocity is the change in displacement, which is the distance essentially, right? Divided by the change, delta means change, right? We learned that somewhere in grade 10 or something. Delta y over delta x, yeah. Change of time elapsed. Okay, so a rock falls from a high cliff. The position of the rock is given by y equals 16t squared. What is the average speed during the first 2 seconds of the fall? So, how do we do this? Well, how did we do it over here? We found out the change in displacement, so we knew it was 200 miles. So how am I going to figure out how much I traveled? At 0, how much have I traveled? 0. 0 goes in for t and you square it, yes, and you get 0. So after the first 2 seconds, what would that be? 16 times 2 squared, what is that, 64? Yeah? So we're going to use average velocity. So average velocity is equal to the change in displacement. So it went from 64 from 0. So if you want, you can just put 64, but I'm gonna show my work. I'm actually subtracting 0 because if I started somewhere else, it wouldn't be 0, right? And then the change of time, again, it's 2 seconds minus 0. So what do I get? 64 divided by 2 is 32. And what's my units? It just says seconds, so let's just say feet per second or something like that. I'll say it's in feet, whatever. For this example, the rock's instantaneous is the speed of the rock at a given instant of time. So I guess what I'm trying to explain to you is at the instant at 2 seconds, we travel 64 feet or meters, whatever the unit is. That's the instant, right? So if I do 6 divided by 2, that, because I traveled 2 hours, at that 1 second in time, it's the same. It's not always like that. So let's find what the instant is at 2. Okay, so we're going to use our TI-84. TI-84. Well, or 83, I don't really care. Okay, so So we're going to type this in. So bracket 16 bracket 2 plus h bracket squared minus 16 bracket 2 bracket bracket divided by h. Okay. I forgot the squared? Oh, I did. All right, thank you. Let's insert it. Okay, so I'll wait. So go to your second function of your window and go to table set. We're going to start at 1. We're going to put 1. And then we're going to look at the table there. Does everybody see? We get a table like that. Go second function. So we just found on our graphing calculator that we get 80 there. Does everybody agree? How do I get 0.1 in my table now? Do it again. Oh my gosh. So go to table set. Change it instead of starting at 1. Go to 0.1. Then go to your table. What does it tell you? 65.6. Now we're going to go to 0.001. 0.01, sorry. 0.01. 64.16. Then we're going to go to 0.001. Did you get 64.016? And if we continue, what do we get? 64.0016. Then we get 64.00016. So as h approaches 0, what is it going to? It's going to 64 feet per second. Okay, let's confirm this algebraically. So we are going to simplify this. Let's see how good we are. How do you do that?
You have to expand.
You need to expand by FOIL. So what do we get? 16, we did. 16, what is 2 plus h, the whole thing squared, going to be? 4 plus 4h plus h squared minus, I'm just going to put 16 times 4. I'm going to do one step at a time, all over h. Is everybody good? Okay, now I'm going to multiply the 16 in. What's 16 times 4? 64 plus 64h plus 16h squared minus 64. Does everybody see what can get canceled here in a second? What? The 64s. Then we're left with 64h plus 16h squared divided by h. I'm sorry? Yes. Factor out the h on top, and we're left with 64 plus 16h divided by h. And guess what we can do then? We can cancel. So if we wanted to actually find the limit as h goes to 0 of 64 plus 16h, can anybody tell me what it is? It's 64. So what we just did there is we found, algebraically, what we found in the table, the instantaneous velocity. Oh, because 0 goes in for h, right? This is just evaluating a limit at that point, right? Yes? Okay. So now we're going to do what's called the average rate of change for f of x equals x squared minus 3x over the interval 1, 3. Does everybody see that 1, 3 is not a coordinate? It's an interval from 1 to 3. Yes? Okay, so what we're going to be doing is, in order to find the average rate of change, essentially it's the change of displacement over the change of time. But in this case, what is it going to be? Essentially it's the change of y over the change of x. Yes? Okay? So in order to find the average, I'm going to call it ARC, average rate of change. Average rate of change. Rate of change. It's going to be f of 3 minus f of 1 divided by 3 minus 1. Does everybody see what I'm doing there? Yes? Well, I'm taking the y values at 3 and the y values at 1, subtracting to get the difference, and then I'm subtracting the x values at the bottom, right? So, what is f of 3? What's f of 3? 9 minus, right? 3 squared, you get 0. Yes? Minus 1 goes in, what do we get there? Minus 2 over 3 minus 1, 2. So what do we get? 2 divided by 2, which is 1. So what's happening there? Well, if I actually go from here to here and make a line, guess what that slope is? It's actually 1. Yes. The secant line. Geometrically, we found the slope of the secant line through f of 1 and f of 3. Does everybody see that? Look at the slope. Up to over 2. What's that slope? 1. That's what we just calculated, essentially. Well, you can, but eventually we're not going to graph these things. You have to be able to do this algebraically, right? Okay, so definition. A secant line is a line, have you heard of a secant line before? Through 2 points on a curve. A tangent line is only through 1. That's the difference between the two. A secant goes through 2, a tangent goes through 1. We can think of an average rate of change. This is the average rate of change through this, is this slope of the secant line. Okay? So, what are we doing here? What did we say is exactly 1 point? A tangent line. A tangent line is the line that intersects the curve exactly once. We can think of this as an instantaneous rate of change. So this is the difference between the two. So if I look at this visually, I am taking the slope of between these 2 points, and that's just an average, right? If I want to focus on in, I need to actually go to a specific thing. So for instance, if I want to know the instantaneous rate of change at 3, I need to focus right here and try to find the slope there. So I think I have a nice little, let me see here. I have a creative pen, I think. Well, the magic pen is where I was going. If I make a box right here, it focuses in. And so if I look at this, do you see that the slope is actually way bigger than what we just calculated, right? The slope is way steeper. And the tangent line means it's gonna just touch that black curve just once here. Do you see what I'm saying? After 23 days, 150 fruit flies were grown in a laboratory. After 45 days, the population of fruit flies increased to 340. Find the average rate of change in the fruit flies. So what are they asking you? This is what you're supposed to get from this. What are they asking you when they say average rate of change? You are finding the slope of the secant line. If I said I wanted the instantaneous rate of change, I would find the slope of the tangent. Okay, so we are just finding the average rate of change. So here's the point, and here's the point, and we are trying to find that slope of that secant line there. Do you see that? So how do we do that? y2 minus y1 over x2 minus x1. You remember that? That's the change of y over the change of x. That was your delta. Yes. See how this is all coming together? Okay, so what's my y value there?
340.
340. Subtract. What's the y value here? 140. You want a rock? Okay. Divided by, what's my 45 minus 23? What do I get there?
You have to write that out during the question. You just see it at the question.
Well, it does say it right there, 190 over 22, right? And so if I actually divide that, and again, this is fruit flies per day, so this is approximately 9 flies per day. So I found the average amount of flies per day that were growing. On average, it grew 9 flies per day. So instantaneous, if I wanted to know on day 30 exactly how much it increased, that would be the instantaneous rate of change. Does that make sense to you? And I would have to find the tangent line at 30. So that slope looks like it is a little steeper, okay? Now, if we wish to find the average rate of change at point P, we must move point Q closer. So we're saying if we want to find the instantaneous at P, and we want to find a better average, move this point closer, and then the slope will be a little bit better approximation. That's what they're basically trying to say. So we're going to create a new secant line. But at some point, if we shorten our secant line, if we take this Q and move it closer to P, what's going to happen? It's actually going to become P, and it'll become the slope of the tangent line, right? So now this will become the rate of change at point P, or the instantaneous rate of change. Okay, so here's where we're getting into the slope of a curve at a point. This should go on your little card, right? You see I have it highlighted? There's a reason. Okay, so the slope of a curve at a point P of A and F of A is the limit as h goes to 0, meaning that point is coming closer and closer and closer and closer to that first point, and you're finding the difference of the y's, and the h, that means the x values are coming basically to nothing for the distance between the two. So that's why it's going to 0 without being 0. Of course, provided the limit exists. The tangent line to the curve at P is the line through point P with this slope. Here's a new definition in case you didn't know that. The normal line to a curve is the line perpendicular to the tangent. Does anybody remember from grade 10 what we know about slopes of perpendicular lines? They're not the same. Parallel are the same. Perpendicular are, yeah, negative reciprocals or opposite reciprocals, however you want to say it. What does that mean? If the slope is 2, then something that's coming off of here at 90 degrees, what would this slope be? Negative 1/2. Does everybody see what I mean by negative reciprocals? Yes? Okay. So we're going to find the slope of the curve of f of x equals 4 minus x squared at x equals 3. And you might say, well, wait a second, how do we find that? We just had a formula on the other, it just said there's a formula there. Remember the slope was, right? Remember the slope from the other side? Yes? It was the limit as h goes to 0 of f of a plus h minus f of a, all divided by h. Okay, so here's the thing. A's and h's don't make sense unless there's actually numbers here, right? So they're actually giving you what here for your x? They're giving you the a this time, right? Okay? Yeah. Okay, so this means this is the limit as h goes to 0 of f of 3 plus h minus f of 3 divided by h. And you might say, well, that's not getting us anywhere. But we can actually plug this in to here, right? What's f of 3 plus h? It is, this is my input. It's going into the function. What do I get when I put it into this input here? Yeah, very good. And then when I plug 3 in, what do I get? 4 subtract 9 is minus 5. I'm just going to use some brackets there just so you can see that. Negative 5. Because 3 goes in there and I get 4 minus 9, yes? And this is, of course, divided by h, and I still have the limit here as h goes to 0. I'm running out of room. I don't know why I didn't give you enough room here. Okay, so now I'm going to FOIL this out. 4 subtract, what do I get when I FOIL that? 9 plus 6h plus h squared plus 5. Does everybody see that? And that's, of course, divided by h. So equals the limit as h goes to 0. Okay, so then I get 4 subtract 9 minus 6h minus h squared plus 5 divided by h. Does everybody see? The 4 and the 5 will cancel the minus 9. Yes? Now, to answer your question about why do we need when the h is 0, we're going to get rid of the h in a second here. Do you see that? If I factor out the h, I get minus 6 minus h over h. Does everybody see that? Now the h's will cancel. Now I can plug the 0 in for h, and what do I get? Minus 6. So what does that mean? The slope at that one point is minus 6, yes? Okay, so now you have to recall from, again, grade 10, this is your point slope form. We kind of reviewed this when we had that one review worksheet. So what are we going to plug in? We have a point. What is the point when x is 3? 3 comma what? No. You have to plug it into the function. What would the y value be? I heard it, minus 5. Yes? So it's going to be y minus 5 equals the slope, which is minus 6, x minus 3. Well, we don't usually leave it as minus minus. So it's going to be y plus 5 equals negative 6x minus 3. So there is the equation of the tangent line right there. Okay, so now we're going to take our graphing calculator and graph this. So we're going to graph, go to your y equals, and we're going to graph 4 subtract x squared. Okay? And then we're going to graph the equation we just did. However, we can't plug into the calculator y plus 5 equals. We got to move the 5 over to the other side. Does everybody understand that? So I am going to put negative 6. And by the way, you have to use the negative here, not a subtraction, right, for negative. So it's going to be negative 6 bracket x subtract 3, yes? And then because I'm moving the 5 over to the other side, it's subtract 5. Okay, and so then we're going to go zoom 6. Zoom 6. Okay, so at 3, 1, 2, 3, right here, this is the tangent line going, intersecting right there. So I just drew it there. So, oh, way too big. So does everybody see that that is the tangent line hitting when, remember what the point was at 3? 1, 2, 3, it was 1, 2, 3, 4, 5, minus 5 right there. There's the tangent line going through that point right there. Okay, how do we find the equation of the normal line? It's the negative reciprocal. So it's going to be the same point, but it's going to be the negative reciprocal. So y minus 5 equals, instead of negative 6, it's going to be positive 1, 6, x minus 3. So then y plus 5 equals 1, 6, x minus 3. Okay? So some things that have come up here today. Really important things is the difference quotient. So you're going to be using this a lot. The a plus h minus f of a over h, that's the difference quotient. And that can be interpreted as the slope of the secant line. But when h goes to 0, it now is the slope of the tangent line. So remember, the average rate of change was the two things subtracted, but h wasn't 0. H was the difference between the y values. The instantaneous is when h actually goes to 0. So you see it's the same thing, it's just the x values, there's no difference between the x values at that point. Okay? So, last page here. Holy. T seconds after liftoff, the height of a rocket, it can be modeled by the position function f of t equals 3t squared. What is the instantaneous rate of change at f at t equals 10? So what do we have to do then? We need to find the limit as h goes to 0 at the value 10, right? So why don't you find f of 10 first? What's f of 10? 300. Okay. Let's find f of, we're going to use, do you want to use t plus h? So 10 plus h. So what would that be? 3 times 10 plus h, the whole thing squared. It's going into that function machine. We're going to square it. So we get 100 plus 20h plus h squared. Sometimes it's easier to pre-do these things than having it on the actual difference quotient. Oh, sorry, that should be 60h plus 3h squared. Okay, so I pre-calculated the stuff that's going on top. Does everybody see that? So I'm doing the limit as h goes to 0 of f of 10 plus h minus f of 10 divided by h. But I've already figured out what those things are, okay? So the limit as h goes to 0, 10 plus h, f of 10 plus h was 300 plus 60h plus 3h squared. Subtract 300. All divided by h. Do you see the 300s now cancel and I can factor out an h? This is what's going to happen every single time. So the limit as h goes to 0 of h bracket 60 plus 3h divided by h. Do you see the h's cancel? And we're going to sub the 0 in for h, and what do we get? We get 60. And what does that mean? The slope is 60, and what does the slope represent in this case? The slope of the tangent line, but it is, what's the units, I guess is what I'm looking for. How about feet per second? Good try though. Okay, we learned a lot today. It's going to all make sense in a second here. Here's the summary then. A secant line intersects a curve at 2 or more points, while a tangent line intersects only at 1 point. The slope of a secant line is calculated by m equals y2 minus y1 over x2 minus x1. Everybody good? Okay. So we can the blank rate of change of a quantity over a period of time is the amount of change divided by the time it takes. What am I looking for? The average versus the blank of a secant line between 2 points on a distance time graph would give us the average velocity. So what average velocity is the slope of the secant line. Very good. While the slope of the blank line at 1 point gives us the instantaneous, the slope of the tangent line. The slope of a curve at a point is the same as the slope of the tangent line at that point. What is the equation of the tangent line? Yeah. Yeah, so if first I have to find the slope. The slope is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. And then if we wanted to find the equation, it is y minus y1 equals slope x minus x1, right? If you want to find the normal line, that is the perpendicular, we use the what of the slope for the normal line? The negative reciprocal. For example, if the slope is 2, then the normal line would have a slope of negative 1/2, yes?